Okay, hope everybody's doing well. We're going to try something new. Um, I'm going to stream by myself without Jason, and I'm going to cover a couple of news stories for you guys. We're going to call it Fix Your Gut News and Views, and then eventually Hooper will be joining me on the live stream, but this is a test run for this, so hope you guys enjoyed. I'm going to go over one news story and two studies, and I'm going to discuss them. And so let's begin. Zantac is prescribed 15 million times a year. So how did it become a potential cancer risk? The stomach acid blocking drug Zantac was prescribed more than 15 million times a year with little worry about the safety of the medication available for decades. But it had been harder to get the drug since September, with the Food and Drug Administration said testing showed versions of Zantac and its generic ranitidine contained a probable carcinogen. The French drug maker Sanofi recalled Zantac from drugstores and retailer shelves. A half dozen generic drug makers pulled ranitidine from the market. How did a drug routinely used by millions of heartburn sufferers and available with or without a prescription become a potential cancer risk? It's a question the FDA, which is the United States Food and Drug Administration, drug manufacturers, and consumers want answered. Every patient who comes into my office now, it's almost the first thing that comes out in conversation. What about ranitidine? What should I do with the medication? Should I come off of it or on it? Said John Erstoff, a gastroenterologist in Meridian, Connecticut. In September, the FDA found unacceptable levels of the probable carcinogen NDMA, or nitrosodimethylamine, in Zantac and generic medications. The regulatory agency wants manufacturers to test and recall the drugs if NDMA levels exceed its standards. The FDA extended the voluntary recall to a similar drug, nizadine, sold under the brand name Axid, if testing shows NDMA exceeding daily limits. There's also a chart here that shows Zantac prescription studies since 2010. 2016, at least 15 million people in the United States were using Zantac prescriptions. The FDA said consumers might want to choose different medications. The agency tested samples of over-the-counter alternatives such as Pepcid, Tagamet, Nexium, Prevacid, and Prilosec and found no NDMA. The agency's investigation of ranitidine seeks to uncover the root cause of NDMA found in the commonly used medication. Researchers at Memorial Sloan Kettering Cancer Center in New York are assessing whether people who use Zantac or generics face a greater cancer risk. The warning first came from Valisure, a Connecticut-based online pharmacy and laboratory discovered NDMA and several forms of the drug and alerted the Food and Drug Administration. The private company said clues of the drug's potential risk could be traced to medical studies published since the early 1980s. NDMA is the same carcinogen that led to widespread recall beginning in July 2018 of the blood pressure-lowering drugs valsartan and lorcertan. The blood pressure recall stemmed in a new manufacturing process first used by a drug ingredient factory in China. Zantac's risk appears to be unstable nature of the drug itself, said Valisure CEO David Light. This isn't something new. Bad manufacture processes overseas, like what happened with valsartan and lorcertan, which are they are ACE inhibitors, second generation ACE inhibitors. Light said, blood pressure medications, for y'all out there who don't know what ACE inhibitor is. It is often viewed that this problem with ranitidine has been since the 1980s. It's a much more serious issue. Nobody found it. The Food and Drug Administration tested about 1,500 samples of Zantac and generic versions of ranitidine and found "quote unquote" low levels of the probable carcinogen. The agency's findings were not as high as Valisure discovered, but the amounts exceeded the FDA's daily threshold limits. Less than 1 week after the FDA announced Zantac and its generics contain NDMA, Health Canada halted distribution of the drugs. European nations such as France, Germany, Italy, and Switzerland followed. Taiwan warned it would fine pharmacies keeping ranitidine on shelves. Pakistan banned all distribution and manufacturing of the drug. The FDA has taken a more measured approach. Beyond the voluntary recalls, the agency is testing samples and published testing standards for worldwide regulators and drug manufacturers to gather evidence on how the carcinogen is formed. Yeah, so all these countries pull the Zantac off the shelves or halt its distribution or its production, but the FDA is like, gotta do some further testing to see if it's going to cause any issues. Yeah, our Food and Drug Administration is corrupt, in bed with the pharmaceutical companies, in my opinion. Janet Woodcock, director of the Food and Drug Administration's Center for Drug Evaluation and Research, told the House Committee on Energy and Commerce on October 30th that the ranitidine carcinogen is a quote-unquote different problem for other manufacturing flaws such as drug ingredient contamination and blood pressure medication recalls. This is a product that was approved in 1984 and it's used worldwide, Woodcock told the committee, and nobody found it. The FDA asked pharmaceutical companies to examine whether ranitidine's ingredients are exposed to nitrates during manufacturing. Our chemists believe that it's formed by the molecule ranitidine reacting with something either during the manufacturing synthesis or during the finished dosage form or during storage, Woodcock told the committee last week. The FDA studied how the drug reacts with fluids in the stomach and intestines. During such stimulated tests, the FDA did not find evidence Zantac formed carcinogens. The FDA said it must test the drug in humans to evaluate whether it forms NDMA. Valisure tested Zantac in stomach-like fluids with and without added nitrates, chemicals commonly found in the foods in the body. Remember, your saliva has a lot of nitrates in it, too. So you're swallowing that, it goes in your stomach. When the chemicals were added, Valisure found NDMA levels for one tablet of Zantac reached more than 3,100 times the FDA's daily threshold. Like I said, testing the drug with added nitrates created stomach-relevant conditions. Ingesting nitrate-containing foods like hot dogs can significantly increase stomach levels of nitrate, like I said. These foods are often eaten by individuals either before or after taking antacid products. Studies pointing to the risk date to 1980s. In 2016, Stanford University researchers tested urine samples of 10 people who took 150 milligram tablet of Zantac and found NDMA levels far greater than the FDA's daily limits. William Mitch is a Stanford University professor of civil and environmental engineering who studies wastewater converted to drinking water. He says the Zantac urine study was a quote-unquote chance finding from a peripheral field after a study on potential NDMA contamination in drinking water. He said it should be followed by a more robust study using the FDA's testing methods. The challenge is there's so much concern about cancer risks. Could you get approval from someone to eat a Zantac and collect the urine sample, Mitch said? Nothing such a request would be odd and ethically challenging, given the drug has a known carcinogen and remains on the market. Leor Bronstein, a Memorial Sloan Kettering oncologist and researcher studying ranitidine and cancer risk. He does not want to discuss the study until the findings are published in peer-reviewed journal, according to Caitlin Hu, a hospital spokesman. Licensed studies conducted in the 1980s raised concern about potential safety risks. In the city's position to the FDA, Valisure says Zantac's originator, Glaxo Research Group, conducted its own study in 1987 after numerous studies raised concerns about ranitidine. The Glaxo study examined stomach contents of people who took the drug. It found people had no significant increase in nitrosamines such as NDMA within 24 hours of taking ranitidine. Like I said, the study's testing samples were less accurate, and researchers discarded stomach samples that contained ranitidine. Without these samples, researchers would not find NDMA or nitrosamines that formed as a result of taking the drugs, Light said. So the GlaxoSmithKline study, of course, it was flawed. Imagine that. Like I said, the Stanford study in his lab's own analysis shows the potential health risk for people who took the drug. The negative effect of exposure to this drug and its formation of NDMA is something that has created a huge public health problem, he said. We're going to be dealing with this going forward. One thing that this article doesn't look at is that H2 antagonists, they inhibit histamine, the H2 receptors being primarily in the stomach. And so histamine is important for the signaling of the peritoneal cells in the stomach to produce stomach acid when you ingest food. And stomach acid provides many forms. It activates pepsin, so proteins are digested in the stomach. It helps, if your stomach's acidic, it helps to signal the body to tighten up the LES so you don't have reflux up into your esophagus. The stomach acid in and of itself breaks down food. It kills pathogens, because even though we cook food, it's still going to have bacteria on it from the plates and our hands and forks and stuff. So none of the food that we eat is sterile. So it helps prevent against bacteria, setting up shop in the stomach or the small intestine after we ingest them. And to have proper stomach acid production and proper lower pH levels when we're ingesting our foods. Stomach's supposed to be a very acidic environment. Now, not that bacteria doesn't live in the stomach. There are probiotic strains of bacteria like Lactobacillus and Peptostreptococcus that live in the stomach. But one thing this study did not mention, though, however, is that when you take ranitidine or an H2 antagonist or even a proton pump inhibitor, which is a different class of drugs, because H2 antagonists only work for about 12 hours, proton pump inhibitors can work anywhere between 24 to 72 hours. So most people have to take one or two H2 antagonists daily to reach a therapeutic benefit. They have to usually take one around noon and one before bed. But the problem is with the use of these medications, other than NDMA formation within the stomach, is that if a person has H. pylori and it goes unchecked and they keep taking these acid-reducing drugs, H. pylori could, through the potent endotoxins as it being a proteobacteria, which proteobacteria produce very, very potent endotoxins that the body's immune system react to, can lead to gastritis and inflammation and ulcers, and if left unchecked, can cause stomach cancer. So just taking these medications frequently in and of themselves, if you have any gram-negative, specifically, stomach dysbiosis, gram-positive too to some degree, but mainly gram-negative, especially proteobacteria like H. pylori, that inflammation to the endotoxins and immune reactions to the endotoxins that can happen when having a dysbiosis of that can lead to stomach cancer in and of itself. H. pylori is the main cause of stomach cancer. So that could be outside of the reason why the studies even far back have shown a link between H2 antagonists used in stomach cancer that could directly be separate from NDMA production. Very interesting article. I very rarely recommend the use of acid-reducing medication, and acids tend to be safer if needed. There's a condition called Zollinger-Ellison syndrome where a person has too many gastrin-producing non-metastasis type tumors. They're benign tumors, but they can secrete gastrin, which is a hormone which increases stomach acid, so a person can have too much stomach acid if someone's dealing with Zollinger-Ellison syndrome. So in that case, most of the time, Zollinger-Ellison syndrome, again, is triggered by some sort of dysbiosis in the stomach that can cause it. But if not, then the use of H2 antagonists or proton pump inhibitors long-term might have to be used. But that's a rare circumstance. And I'll put links down and below about streams that Jason Hooper and I have done about reflux, and as well as any articles that we have on Fix Your Gut about acid reflux and H. pylori. All right. Next, from Silence Daily, dangerous bacteria communicate to avoid antibiotics. Source, University of Copenhagen, the Faculty of Health and Medical Sciences. A bacterial infection is not just an unpleasant experience. It can become a major health problem. Some bacteria develop resistance to otherwise effective treatment with antibiotics. Therefore, researchers are trying to develop new types of antibiotics that can fight the bacteria and at the same time trying to make a current treatment with antibiotics more effective. Researchers are now getting closer to this goal with a type of bacteria called Pseudomonas aeruginosa, which is notorious for infecting patients with a lung disease, cystic fibrosis. In a new study, researchers found that bacteria is sending out warning signals to their conspecifics when attacked by antibiotics or the viruses called bacteriophages, which kill bacteria. We can see in the laboratory that the bacteria simply swim around the dangerous area with antibiotics or bacteriophages. When they receive the warning signal from their conspecifics, you can see in the microscope they are moving in a neat circle around. It is a smart survival mechanism for the bacteria. It turns out that the bacteria use the same evasive maneuver when infecting humans. It may explain why some bacterial infections cannot be effectively treated with antibiotics, says researcher Nina Holland Kroeshabu, assistant professor of the Department of Veterinary and Animal Service Sciences and part of the Research Talent Program UCPH Forward. One united organism. In the study, which is a collaboration between the University of Copenhagen and the University of California, Irvine, researchers have studied the growth and distribution of bacteria in petri dishes. Here, they created environments that resemble the surface of mucous membranes where an infection can occur, as in the case of the lungs of a person with cystic fibrosis. In this environment, researchers can see both how bacteria usually behave and how they behave when they're affected by antibiotics and bacteriophages. It's quite fascinating for us to see how bacteria communicate and change behavior in order for the entire bacterial population to survive. You can almost say they act as one unified organism, says Nina Mullen, Holland, Crochet possibility of blocking. The Pseudomonas aeruginosa bacteria are such a big problem that they found in top category critical in World Health Organization list of bacteria, where new types of antibiotics are most urgently needed. Therefore, the researchers are excited to make new discoveries about ways in which this type of bacteria behaves and survives. Infections with this type of bacteria are a major problem worldwide with hospitalizations and deaths. That is why we're really pleased to be able to continue new knowledge that can potentially be used to fight this bacteria, says Nina. However, she emphasizes that it will take a long time for the new knowledge to result in better treatment. The next step is to research how to affect the bacterial's communications and warning signals. This clears the way for the use of drugs in an attempt to prevent that the warning signal is sent out in the first place. Alternatively, you can design substances that may block the signal from being received by other bacteria, as could potentially make treatment with antibiotics or bacteriophage viruses more effective, concludes Nina. Yeah, Pseudomonas is a gram-negative bacteria. Produces very potent biofilms. Many people with cystic fibrosis will get Pseudomonas infections in their lungs because their body is improperly able to make mucus and clear mucus through a genetic polymorphism. People with cystic fibrosis. So it doesn't surprise me that bacteria are able to communicate. Microorganisms are able to communicate with themselves and warn them of how to avoid antibiotics and even natural antimicrobial agents to some degree. So it'll be very interesting what research comes out of this. And finally, very, very interesting study. Ketogenic diet helps tame flu virus from Yale University. A high-fat, low-carbohydrate diet like the keto regimen has its fan, but influenza apparently isn't one of them. Mice fed a ketogenic diet were better able to combat the flu virus than mice fed food high in carbohydrates, according to a new Yale University study published November 15th in the journal Science Immunology. The ketogenic diet, which for people includes meat, fish, poultry, and non-starchy vegetables, activate a subset of T cells in the lungs not previously associated with the immune system's response to influenza, and enhancing mucus production from airway cells that can effectively trap the virus, the researchers report. Very interesting. It seems like a ketogenic diet activates Th1 cells within the lungs, especially if someone is dealing with the flu virus, because Th1, which stands for the helper cells subset 1, just like you have Th2 and Th17, Th1 primarily deals with viruses and gram-negative bacteria, where Th2 primarily deals with yeast, parasites, and gram-positive bacteria. So it's very interesting that going on a ketogenic diet will activate Th1 and will help people overcome viral infections, including influenza. It may not be helpful for someone who's Th1 dominant to go on a ketogenic diet, or someone who's dealing, for example, who are very young, who contracted the swine flu, which was actually the body's reaction to swine flu in and of itself, greatly increasing Th1, causing mass inflammation in the lungs and causing cytokine storms. So pretty much the body's own immune system were killing people with the swine flu. That's why the elderly actually just got a very mild case of the flu from the swine flu, because it didn't trigger such a violent Th1 immune reaction. So yeah, I mean, in some cases, if you're not Th1 dominant, and I'll put a link to Th1 from Joe Cohen from Self Hacked in the show notes to determine if you're Th1 dominant or not. Then it may be very beneficial, if you're trying to overcome the flu, to eat less carbohydrates, especially eat less sugar. This was a totally unexpected finding, said co-senior author Akio Iwasaki. The Waldemar von Zedwitz, professor of immunobiology and molecular, cellular, and developmental biology, and investigator of the Howard Hughes Medical Institute. The research project was the brainchild of two trainees, one working in Iwasaki's lab and the other with co-senior author Visha Deep Dexit. The Waldemar von Zedwitz, professor of comparative medicine and immunobiology. Ryan Maloney worked in Iwasaki lab, which has found the immune system activators called inflammasomes can cause harmful immune system responses in their host. Emily Goldberg worked in Dexit's lab, which has shown that the ketogenic diet blocked the formation of inflammasomes. The two wonder if diets can affect immune system response to pathogens such as the flu virus. They showed that mice fed a ketogenic diet infected with influenza virus had a higher survival rate than mice on a high carb normal diet. Specifically, the researchers found that a ketogenic diet triggered the release of gamma delta T cells, immune system cells that produce mucus in the cell linings of the lungs, but the high carbohydrate diet did not. While mice were bred with a gene that codes for gamma delta T cells, the ketogenic diet provided no protection against influenza virus. Interesting. So the mice that were not able to produce gamma delta T cells, the ketogenic diet did nothing. This study shows the way the body burns fat to produce ketone bodies from the food we eat can fuel the immune system fight the flu infection, Dexon said. That's a very interesting study. I wonder if it can be replicated in humans. But yeah, if you're not Th1 dominant and you're suffering from the flu, you probably want to limit the amount of sugar you're taking in, or you might even want to go to a ketogenic diet for a brief period of time. Make sure you're getting a lot of good, vegetables on it to maintain healthy fiber for the microbiome, and you're getting a lot of healthy fat like grass-fed butter, grass-fed meat, pastured eggs, pastured chicken and poultry, wild-caught fish, extra virgin olive oil, coconut oil. But yeah, I mean avocado oil. That's a very interesting study. If you are dealing with the flu and you're not Th1 dominant, then it may be helpful to go on a ketogenic diet for a short period of time if you're not doing it already, to help you combat the flu virus and have less inflammation in your lungs. All right, that's it for this week's episode of News and Views for the week of get my calendar up, the 25th through the 29th. I hope everyone listening here in the United States have a happy Thanksgiving with your family. Take care. Hopefully you guys enjoyed this. I will be doing this again soon, and hopefully eventually Jason Hooper will be joining me